So welcome to welcome to technical session 4D. So on behalf of Global Knowledge Research Foundation, I welcome you all to the 7th International Congress on Information and Communication Technology through Zoom. So there is a note for the presenters. You will be given 10 to 12 minutes for your presentation and 2 to 3 minutes for the question and answers. So I'll give a reminder check around 10 minutes. So please stick to the time schedule as we have parallel sessions going on continuously to avoid the further delay. Yeah, thank you so much for your presence, for your valuable presence all here. So to get started, just a minute, I would like to invite our session chair. She's just joining us, Dr. Latika Desai. She's just connecting. Could you please wait for 2-3 minutes?
OK ですか、半田先生。
Dr. Latika Desai?
何て言ってますか、
Yes.
半田先生。
Yes, ma'am, you're here, right?
チェアの先生を待ってる。ちょっと待ってくださいって。
So, Dr. Latika Desai, yes, ma'am.
Actually, I was disconnected, so
No problem, no problem.
previous conversation I can't get.
Now, can you connect to us?
Yes,
Now,
yes.
yeah, okay, I've made you the post. Yeah, so we will begin with the. So, Professor Latika Desai is working as an associate professor in Department of Information Technology. She has done her PhD in 2019 from Savitribai Phule Pune University. She has total 24 years of teaching experience. Her areas of interest includes digital electronics, data security, and embedded system IoT cloud. Thank you for your valuable presence, ma'am. So for now, we'll begin with the first presenter, that is Maki Arame. Are you here?
Yes.
Yes, yes. So you can start sharing your screen.
OK。はい。Our presentation is Maki Arame and Junko Handa. And Handa 先生、準備 OK ですか？
はい、
You can
OK
start.
です。
Yes,
Hi.
please. So who is going to present the presentation, Junko Handa or Maki Arame? Who is going to present?
どっちで回しますか？
半田先生の方で、私は途中で出れなくなりますんで、はい。
あ、はい。I will be the presenter.
Okay.
Junko Handa.
Start sharing your screen, please.
Mhm.
Please start faster. We cannot waste the time.
OK。はい。じゃあ、半田先生、共有をやってもらっていいですか？共有で。
はい。行きました。
はい。
じゃあ、スタートします。あれ
Yes, please.
音声大丈夫か？
やってください。再生してください。
聞こえる？
音小さいですね。
So what you can do, if it is a video, just mute yourself so that we can listen to you, or else the voice will get clash. Is this a recorded video, recorded presentation, recorded one, right?
Mhm.
So yes, so okay, begin please. Thank you. The volume is not loud. Better.
It aims at practical application and commercialization from basic research. This is one of the SIP projects about developing levels of driving automation. Level 3 is functional automation, when the future requires a driver must drive. One of our studies suggests that conventional based on observing English differences compared to fixed. This study focused on self-regulation as a way to assist learning. Zimmerman suggests that self-regulation is an important factor influencing academics. In recent studies in self-regulation, there are many studies that relate self-regulation to resilience. These previous studies suggest that working on goals and providing an opportunity to learn from mistakes is a useful way to improve resilience and self-regulation. Also, this study is to examine the different types of teaching materials and self-regulation. Instructional design is used to design of learning with tasks and activities. Learning topics and procedures were designed for target learning to achieve the main goals. Determine the goals, teaching content that make up the learning outcomes, which result in information. According to research, self-regulation model in learning and goal-setting phase is important in self-regulation process for one's key. Development study examines the goal essential study can be found very important mistakes to study various learning styles in configuration learning. Research question 1. For teaching material that includes setting goals and supporting reflection using instruction design method is developed, it is assumed that it is effective for resilience. Study the same contents were used at different deliveries. Extra material to the such question 2. Teaching material that encompasses setting goals that supporting reflection using interactive materials. It is assumed for people with resilience. This is now by the house and information academic performance. Variable regulation from strong. This study explores relationship. This study one previous personality survey that would make it four processes. This was but also another far of this is the number of respondents is the same. This result was in the interactive material of the graph shows the post score for of included There was no difference. This is the result of
The volume is too low. Can you increase the volume?
うん
This is the result of interactive
うん、
active reflective learning
どうしたらいいんだ。
study. This is the result of the video material.
Better. Thank
Learning
you.
styles were not statistically significant. Result of decision tree analysis. The interactive and video material were the same group. Decision tree analysis showed a little effect on learning style. Conclusions. In this study, 3 types of teaching materials of automated driving level 3 were developed using ID and were examined whether they could support self-regulation for learning. Mixed materials that require a learner to go through the learning content by himself. A learner should learn actively to perceive the text information. Interactive material that encourages learners' reflection by asking questions and giving feedback. It promotes a learner to reflect what he learns. Video material that learning content with explanation and animation. A learner can receive clear information of learning contents by just watching it. Teaching material that encompasses setting goals and supporting reflection using ideas effective for low resilience. The interactive material was effective for low resilience. Effective delivery methods differ depending on learning style. Limitations and recommendation. There are some limitations in this study. The interactive material used in this study did not include prompt feedback depending on the learner's understanding. For the future studies, simulation type interactive material will be used. There was a correlation between pretest and resilience levels, but it has a low correlation. This study used pretest score as a proxy variable for self-regulation abilities and skills. However, it should be considered to use more appropriate or accurate value. Thank you for attention. Thank you. Verification of
あ、なんだそれ。そう、
Thank you. Thank you for your presentation. So, Junko, Handa, and Makiana, you both have presented, right? I'll make a note of that. Thank you so much. The participants can drop their questions on the public chat forum, which is open for all. Yeah, thank you so much. Okay, so we'll move further to the next presentation. That is by Theodosius. Are you here?
Hi everyone. Yes, I'm ready. Let me share my screen.
Yes, please, Nancy, stop sharing. Yeah, you can share your screen.
Can you see the slides?
Yes, I can. You can start. Thank you.
Yes.
Okay, perfect. Excuse me?
Nothing, you can start. You can start.
Okay, perfect. Hello everyone. Good morning. I'm Theodosios Gammas. I'm the head of research and development at the Micro Lab, which is a lab concerning distributed microcomputer systems at the Department of Mathematics in the University of Ioannina in Greece. And on behalf of my colleagues, Vasilios Karaiskos and Dr. Sotirios Kontogiannis, I would like to present our work related with evaluation of cloud databases as a service for industrial Internet of Things data. To begin with, let's see the table of contents of this presentation. First of all, we will see some introductory information. And secondly, we will talk about the architecture of the industrial IoT system. Thirdly, we will talk about the database performance evaluation schemes, and we will present experimental results while we will conclude with the future work and the conclusions of this work. Introduction. First of all, Industry 4 accelerates with a fast pace, meaning that information arises from several kinds of devices, such as machines, sensors, or embedded systems. In this kind of work, we are specifically related with sensors data. So, industrial Internet of Things gathers data from wireless sensors and actuators. We're moving from the digital area to the intelligent one, where we gather data concerning network and application systems. Smart objects can communicate with each other using tools such as big data analysis and cloud computing, creating a cyber-physical production systems. In order to gather the information, the data that we would like to process, there are several kinds of systems or controllers to concentrate the data. The first one is described by the decentralization control system, where independent CPUs are allocated with an individual part of the process. So if one of them fails, the other CPU will continue executing. The second controller is called programmable logic controller, where we do not imply the approach of centralization or non-centralization, meaning that a single PLC or a CPU will control the whole process. On the contrary, individual PLC databases would need to be created in the SCADA system software. The first database system that we would like to talk about is the MongoDB. It is an open source document-based NoSQL database, which is supported commercially since 2007. There are several operations that we can do with this kind of database. For example, sorting, secondary indexing, range queries, and nested document querying. Moreover, we can perform the task of insert, read, update, and remove, and manually index, among others. The second database of our interest is the PostgreSQL, which is an open source object relational database system, having more than 35 years of efficient development. This kind of database gains in popularity for its proven architecture, reliability, data integrity, robust feature set, and extensibility. Moreover, it supports a wide variety of data types, including JSON types or binary JSON files. The goal of this paper is to compare the performance in terms of response time, achieved throughput, and loss between the three types of databases, the MongoDB, the relational PostgreSQL, and the PostgreSQL with JSON fields. Now let's talk about the architecture of the industrial IoT system. As we can see on the left side of this slide, we have several concentrators with the yellow color, gathering all the data through the data acquisition using a PLC through the industrial Ethernet port. Afterwards, all the gathered data are collected by the broker. And secondly, they are moving to the server computer, where we can have several applications. We can use agents, or we can store the data in database management system. All those kind of applications are and the server approach is saved on the cloud architecture, and the provided applications can be handled through personal computers, tablets, or smartphones. Now let's talk about the database performance evaluation scheme. First of all, we will see some kind of details about the dataset overview. We will talk about the evaluation metrics, and we will present some experimental results. Dataset overview. First of all, we use an industrial compressor with non-indexed sensory data. It's a real-world application, and we can split the data into tables for PostgreSQL or collections for MongoDB. The number of tables or collections is equal to the 1% of the number of the queries per second on each database system. The total size of the records is around 400,000. The evaluation metrics that we use in this study are the average and the jitter of the response time, the average and jitter of achieved throughput, and the loss. The system architecture that we constructed, it consists from 20 client nodes and a server with the following specifications. Both systems are running Linux, and we have 20 clients with a VirtualBox machine and a server running with 24 cores and 32 gigabytes of RAM. As we said previously, 3 database systems were selected to be tested: the MongoDB, the JSON PostgreSQL, and the relational PostgreSQL. Three use cases were selected to be tested. The first one is the Q1 concerning the insert process of querying. The second one is the select type of query. And the third one is calculation of a correlation function. For example, in our case, it's the average of the features of the sensory data. To continue, we tested 4 types of queries per second as a client throughput: 100, 500, 1000, and 10,000. Now let's talk about experimental results. As we can see from these figures, on the first image, we have on the y-axis the response time in seconds, and on the x-axis we have the client throughput measured in QPS. As we can see, the blue line concerning the MongoDB achieves the faster responses in comparison with both cases of PostgreSQL. In the select query, we can see that the fastest response is get by the relational Postgres, the black line. And afterwards, Postgres with JSON fields and MongoDB follows in time. In the case of the correlation function, we can see that both PostgreSQL and with JSON fields or the relational model achieves equally performance in response time, while we can see that the MongoDB takes a little bit more time to perform the task. Next, we see the jitter plots that will be described later on the tables that we will present. Now, let's talk about the achieved throughput. In the case of the insert queries, we can see that the MongoDB, the blue line, achieves much higher throughput than the other 2 types of the PostgreSQL. In the case of the select, we can see that the relational Postgres achieves the best throughput in the case of the select. And while you can see that for the correlation function, again, Mongo is the best choice for the achieved throughput criterion. And those are the jitter plots. Now, let's see some numerical results concentrated on this table. This case presents the MongoDB performance for the Q1, which means that it's the insert query. We can see for the maximum client throughput of 10,000 QPS, we have the fastest response for the MongoDB. Again, for the select query, the 10,000 provides the best results, and so on for the correlation function. This is the table corresponding to the Postgres JSON fields. And the following table for the relational Postgres. And this is the concentrated table, where we can see for the insert query, MongoDB performs the fastest and with the highest achieved throughput. And for the Q2, we have the Postgres relational winning and both versions of Postgres in the correlation function. Now, let's see some key points. We see that we have some response loss percentages for the relational Postgres and the JSON Postgres. This happens due to the fact that the unique ID mechanism has some latency in the production of the unique IDs. Later on, we can see that we have also losses for the throughput in the case of the relational Postgres in the scenario of inserts, and the second queries of the selection, where those kind of losses are happened due to the fact that the inconsistency in the PG statement extension that we used takes more than 1 second to respond.
Dear presenter, you just have 2 minutes left.
Now let's see the conclusion. As we can see for the insert query, MongoDB outperformed Postgres with 19 to 30% response time, achieving 51 to 55 higher throughput. In the case of the selection queries, the relational Postgres is 4 times faster than MongoDB and 2 times faster than Postgres JSON, achieving 31 to 35% higher throughput. Lastly, in the case of the correlation function, both versions of Postgres perform equally in terms of response time, outperforming MongoDB by 3.6 times. MongoDB achieves 90 to 24 higher throughput than relational Postgres. Now, a few points for future work. First of all, the addition of more client nodes to the network in order to increase the maximum QPS is one option to be tested. Secondly, the enlargement of the database or the increasement of the database of the table size per collection will also be interesting to be tested. Finally, the evaluation of the performance of using binary JSON files is also an option that's worth to be tested. Thank you for your time and your effort to follow this fast conversation, and we can move on to questions if there are any.
Yes, thank you so much.
Okay,
Any
nice.
questions?
Nice presentation. Can you tell me why you are choosing these 3 databases only?
Actually, our first criterion was to choose a non-relational database, which is Mongo, the most famous, and a relational version of it, which is the Postgres SQL. We find that, as most of the people know, that there are 2 typical types of Postgres SQL, one using JSON files in the case of the sensory data that we use in the industry environment that we like to analyze. So we choose the classic relational Postgres SQL and the one with the JSON fields, which uses a package to concentrate the information in a JSON file and then to broadcast it to our systems in order to analyze them and evaluate them.
Okay. And maximum node you are used for your experimentations are 20, right?
Excuse me, I couldn't hear you clearly. Could you
Hello?
please repeat?
For your experimentation, you are used 20 nodes, right? Client nodes.
20 client nodes, yes.
that is the enhancement should be there, right? So how much can you predict that? How much you can increase?
Actually, 20 client nodes is a number that is quite enough, because the most important factor to set in mind has to do with the client throughput, the number of queries that we try to send in parallel at the same time. So that's why we tested the 4 cases of 100 QPS client throughput, 500, 1000, and 10,000 QPS queries per second as a client throughput, which is the most interesting thing to be tested.
Okay, one last question. Have you compared your work with any other researchers with the same work?
Again, I have
Related
some
with the
problems
throughput,
to
related with the response time?
I lost the first part of the question. Could you please repeat it? I cannot hear you clearly.
Other researcher do that?
Actually, to be honest, if I understood your question, we didn't find much simulations or evaluations concerning the industrial IoT sensory data. So there were some other tests concerning pure applications of MongoDB or PostgreSQL, which again shows that in some cases, in most of the cases, MongoDB performs better. But in the case of big data that we have right here, we can see that sometimes PostgreSQL wins in the battle of sensory data concerning big data and industrial IoT data.
Okay, thank you. Thank you.
Thank you so much. Thank you for the presentation. So we'll move on to the next presentation, Lani. Lani El Masida, you're ready? Thank you for your presence here. You can start sharing your screen.
Good day, everyone. I'll be presenting our research entitled Citizen Feedback Analytics for Inclusive Policy Design and Decision Making, a case study in the implementation of low-speed streets. My co-author here is Maria Jihan Sangil, CEO of the LayerTech Software Laboratory Incorporated in the Philippines, and I am Lani Maceda, Associate Professor at Bicol University, Philippines. So this is the content guide of my presentation. So let me proceed with what is the reason for us to in the conduct of this study. Now we want good governance. And governance refers to the decision-making process and its corresponding implementation. Now, since we want good governance, we want to make a decision-making with a data-driven, which means the decision-making will be coming from the collection of data, came from the drawn insights, and that insights would generate a decision-making to make an effective and more efficient solution to our community problems. Now, the settings of the study is at Pasig City. Pasig City is the Center for Commerce in the Philippines. Now, this study is anchored basically on the Macintosh framework of e-participation. This means that the citizens are emerging as producers rather than just consumers of policy. The citizens are being enabled, engaged, and being empowered. Now, this e-participation actually is the use of an online environment and the communication with citizens, which requires specific actions. Now, this is now the objectives of the study. To use citizens' feedback data to understand citizen sentiment and opinion on low-speed streets, look at conversations and opinion groups based on voting patterns, identify key statements, key concerns raised, and to extract insights for Pasig City LG or the local government unit for decision support to better implement low-speed streets. Now, what is the method that we used? We used a mixed method of quantitative and qualitative. Now, the primary collection tool that we use is the POLIS, which I have here the link. The POLIS is a self-reported survey. It has anonymity, and it is an online platform. And there's no double voting on this. It is not being allowed. Now, for the quantitative, the method that we use is we made use of a priori algorithm. For the visualization, we utilize the RStudio and Tableau, while for the qualitative, we employ the natural language processing. Now, in order for us to have a more valid responses, we conducted a ground validation during the closing assembly. Now, how did we do the data collection? We conducted an opening assembly prior the start of voting. Then the voting ran from June 4, 2021 to June 2022, or June 22 to 2021, which is 18 days, to be exact. We had 301 total voters, and they were grouped together. Now we come up with 45 unique statements and 8 metadata. 11,847 votes were cast for all the 54 statements. And computing it, we had an average of 27.15 votes cast per voter. Now, these are the topic groups identified. For the benefits of walking and cycling, we had actually 100% consensus on this. On the Pasig City's transport and implementation of speed limits, we had 60% consensus. Respondents' behavior on use of cars and motorized vehicle, we got 55% consensus and 30% consensus on the direct statements on roads and low-speed streets. For the association rules mining, which statements are associated with the key statements identified? Now, using the association rules, first, we also remove the consensus statements. Then we mine the association rules with support between 0.05 and 0.1 with minimum confidence on point of 0.8. Then we set actually the left-hand side or the consequent to be the key statements identified, which is actually part of this opinion groups identified. Now, if you will notice, on the group A, we have 175 and group B is 126. For the the group A is classified as the pro speed limit. They are the bikers, they are the commuters, and then the pedestrian users. Then the group B are classified as the car owners, which is somehow has a bit hesitation on speed limits. And you will notice the responses we have here are based on the questions given are evident on how these opinion groups are being identified. Now, we made use here of the principal component analysis and the clustering. So you have here the group A here, and then group B is here. Now, what are the key significant findings? We have the following top rules, which were mined in the study. So these are the 4 significant statements identified. We need more information about speed limits in Pasig. Pasig speed limits are enforced regularly. Pedestrians and cyclists should not be on the main road, and low-speed streets increase traffic. Now, let us see the unique voting patterns for opinion groups A and B. As mentioned, the group A's are the bikers. Then the group B are actually those with hesitation or those with car owners. Now, which is, you will notice, the responses also given based on the unique patterns are very obvious on how we group the voting patterns based on the opinion groups of A and B. Now, with the strongest association rules mined with key statements as consequent, like for instance on the road sharing. It says there, for the node, cyclists and pedestrians should stay on their part of the road to avoid accidents. It's confusing for car drivers to share the road with cyclists and pedestrians. These are the antecedents. And this consequent of this is the nodes for X23 is pedestrians and cyclists should not be on the main road. Now, for the strongest association on pollution and traffic, like with the antecedents on node X36, low speed limits will increase pollution and vehicle emission, in which the consequent here is low speed streets increase traffic. For the strongest association, rule mind on the key statement of the antecedent on cars and safe, comfortable, like for node X25, which is the cyclists and pedestrians should stay on their part of the road to avoid accidents. Roads were made for cars for node X22. The consequent for a node X24 is the presence of pedestrians and cyclists on the road increases traffic and accidents. Now, how about for the qualitative responses? We made use of the natural language processing. So these are the key topics mined. For the topic words, these are the topic words. Then these are the labels generated. So we have the labels of road design and purpose, traffic ordinances, traffic signs and enforcement of speed limit, advisories on use of bike lane, regulate speed limit, or the low speed limit. Now, this is some of the sample responses that we got on those labels. Like for instance, on the road label design and purpose, this is actually in Tagalog, you see, but okay, let me just translate it. Somehow it says there that there's no existing design for the roads on roads design. Then for the traffic ordinances, for instance, one comment there is lower speed limit without traffic will get you to your job just the same with higher speed limit and traffic. And some, we are also in Tagalog. Then traffic sign and enforcement of speed limit, it says there to support this one. I drive slowly. It depends on the road or small street to prevent major accidents and protect the pedestrian. I agree that city driving speed should be limited and regulated. Then, for topic label 3, which is advisories on use of bike lanes, it says there, one of the comment there is bike lanes must be exclusive to bikes only. Strict implementation of bikes only on bike lanes. Assign an enforcer to apprehend violators or install cameras. Okay. Now for topic number 4, which is regulate speed limit, sample responses that we collected. I drive slowly. It depends on the road or small street to prevent major accident and protect the pedestrian. I think it's a good idea considering how often accidents happen on Filipino road due to speeding even on pedestrian lane. Now, we conducted, after processing the data, we actually conducted a ground validation for us to check the responses and the process data that we had. So these results were presented to the city government, chief transport planner, and then the stakeholders during the closing online citizen assembly on June 24. Now, as to the education sector, they said or they suggested to conduct a grassroots-based information campaign on proper road use. The engineering sector suggested to explore engineering solutions in traffic management, such as speed calming measures and widening space for pedestrians and cyclists. Also, balance infrastructure development to benefit the majority, which is the pedestrians and public transport users. Then, also another suggestion from the enforcement group, to train officers to effectively work with people and explore contactless enforcement to make face-to-face enforcement as a last resort. Now, this study concluded that the collection and analysis of citizen feedback over a 2-week period via an open-ended voting platform like Polis already yielded key insights that we are able to drive a meaningful conversation among the local government of Pasig and its stakeholders. The study also concluded that a low-speed streets cause traffic and pollution. This was highlighted for future information dissemination campaigns. Now, what's the next step? The next step is for Pasig local government unit representatives and stakeholders. They expressed interest in possibly making the online consultation a regular activity to constantly engage their constituents and stakeholders and inform LGU for the decision making. This case, the methods, the analysis procedure may be replicated by other local government units for various decision-making cases. That's all, and thank you, and good morning there, and good evening here in the Philippines, everyone.
Any
Thank you,
questions?
Denise, for the nice presentation. You are demonstrated your method. Any other methods are there?
We actually had use the mixed method of the quantitative and qualitative. For the quantitative, we actually made use of also of the KII, or the key informant interview, to validate also some of the responses or to come up with additional responses. And then since it is an e-participation, all actually are coming from the ground. All the responses are collected from the ground, and then these are being processed. We made use of a computing tool to process this one. And then for the qualitative, we actually made use of the natural language processing.
Okay. Nice topic, societal use. Thank you. Thank you.
You.
Thank you. So we'll move on further. We have our next presenter, Pratislav Roka. Are you here? Can you hear me? Are you here? So if not, MD Samihullah, are you here? Can you present next?
Yes, I can.
Yeah, you can start sharing your screen.
Okay. Yep. Do I need to turn on my video?
No, that's not necessary. That's up to you.
Okay. Thank you.
Yes, the screen is visible, so you can begin
Yep.
with your presentation.
Okay. Thank you. Thank you, the anchor and the chair of this session, and good afternoon, everyone. I am Mohammad Samiullah. I have completed my PhD from Monash University, Australia, and now I'm working as an assistant professor in the Department of Computer Science and Engineering in University of Dhaka, Bangladesh. So today I'm going to present my research topics. This is a research project funded by the government of Bangladesh, and we have made a heterogeneous clinical decision support system for personalized care. We call it Dr. AI. The problem that we have addressed and the scope of the application is, it has actually in our country, though it is also true for other countries, or especially for improving or the developing countries and the poor countries, there are very inadequate number of doctors compared to the large number of patients. And the doctors, they always have to deal with uncertainty and large variations in personalized treatment, and this is a great challenge. But data-driven AI-based applications becoming popular in this area. Though we need to know AI cannot replace doctors, but this is also true. It can give us a good assistance so that doctors' work become a little bit less challenging. Doctors' workload and chances of false treatment can be reduced because of such systems. So our objective was to develop a platform to assist doctors by suggesting a list of diagnosis and medicines options based on the available symptoms and the complaints of the patient. So what we tried to do we try to combine the knowledge extracted from historical data of the prescription and various medical stores or various clinics, and we take experts elicitation from the books or from the direct interviews, and then we combine them, we form some knowledge base, and then we make some rules from there to do the reasoning and find some recommendation. Machine learning techniques has been used to provide personalized treatment. We have knowledge engineering system based on Bayesian networks to deal with uncertainty. So on the right-hand side of this figure, of this slide, you can see there is a figure that explains the architecture of the whole system, the Dr. AI system. What we actually do here is we get the data from clinical places or the clinics, hospitals, all these places, and then we get some expert elicitation and from some knowledge from the books, and we develop some efficient algorithm for that is based on pattern mining to mine the patterns from the available clinical data, and then we have Bayesian network construction algorithms that combined the knowledge extracted from experts' opinion and from the books. And then finally, we construct some Bayesian network that help us reasoning and finding the possible diagnosis. And another part of the system is based on the expert elicitation and the knowledge extracted from the book, we construct a knowledge base. And this knowledge base will help us to find the best decision recommendations. And these three systems, one is pattern mining based part, another one is Bayesian network based part, and the last one, the knowledge based part. These three combinedly help the decision support engine for diagnosing a new patient based on the available complaint the patient says. And our decision support system provide us a set of medications and a set of tests that the patient has to go through. So this is the main architecture of our system. So what we have done, we built three different teams who work for data collection, learning algorithm development, and clinical decision support tool development. And the data collection was based on EHR. The EHR we developed for the Dr. AI and the EHR of other systems like other clinics and hospitals. And then we get some data from hospitals, those who are handwritten prescriptions. We have done some web scraping, and we extracted knowledge from books, PDF parsing that requires NLP, natural language processing. Then our pattern mining algorithm team developed some pattern mining algorithms, and they also work on the neural network based algorithms, which was kind of the cutting edge technologies we have used here. And the clinical decision support tool was made available to the users through the web app. The mobile app is not yet developed. There were lots of challenges in collecting the data. First of all, people don't want to share their data because of some obligations, some ethical issues. And another thing is, like, when we were scraping the data from website, the websites are not perfectly structured and the data were not authentic enough. Data contains huge amount of noise. Then tagging enormous amount of data from the various sources was really difficult because the well-defined and globally recognized list of disease, symptom, and medications are not available or not easily accessible. And we had to deal with NLP. We had to deal with some incomplete information. And the most important is authenticity of the data was really a big challenge. So how we have collected our data? We collected data from 4 different websites. Those are real well recognized, like MedX, BD, it is in Bangladesh, then MedicineNet, it is in US, and RxList is used in US, and drugs.com, this is in UK. And 150 plus medicine and medical related books were parsed. And Director General of Drug Administration in Bangladesh, their website and their officials help us to by providing some data. And then UCI data repository, it helped us giving some real life data. And from Kaggle, we also extracted some unidentified recognized data. and the real life prescriptions, and our EHR system. These are the sources. What we have done, we have removed the redundancy, we have done some filtering, and we have used some common NLP, applied some common NLP techniques to pre-process the data and make it usable for our system. And then in the transformation and augmentation, what we have done, we need to transform the data by adding some extra information so that the decisions are still trackable, like embedding the source of the information. We have to map the RX. RX means the medicines, and CC, the symptom with the diseases, and with the medicines and the diseases. All these things have to be done. Then we have performed tokenizing. We have done some tagging. We have added weights or importance to particular symptoms and diseases, and we added frequency so that we can find the trend, which kind of symptoms are frequently occurring, and adding temporal values so that we can find periodically happening events. We have performed some pattern mining work, and in order to find important patterns, we have developed some algorithms like uncertain frequent pattern mining. Because the medical data was mostly probabilistic data, we have to done some uncertain pattern mining. We have developed several algorithms that also include weighted association rule mining and predicting historical data. In our rule-based expert system, we have derived some rules from the knowledge base. The knowledge base was constructed from the books, and those books and experts' opinion gives us the knowledge base. Using that knowledge base, we have performed some reasoning by performing some well-known implications systems or implication operations. Then just as an example, I've shown how the rule were working and how the rule looks like. Like here you can see low fever, flu, and bad taste. Maybe you have a COVID or something like this. So our data was working in this on this kind of knowledge base, and the knowledge base was full of such rules. And weight-based feature selection and rule making to order more than one recommendation. So if you have more than one recommendation for a particular patient, then how you are going to order that so that doctors can choose accurately or efficiently. We have used some neural algorithms to give the doctor's best recommendation, and our neural algorithms constitute of the multi-layer perceptron, bi-LSTM, LGBM, and the rule-based classifiers. When we use a bag of classifiers and use the majority voting technique, we got 93% accuracy in training data and 90% on testing data. And we have developed a web system. You can visit www.http, it should be draibd.com. That should be enough. Don't need to type HTTP. And what we have done, we have used Python to develop our system. And this is a plugin based ever extendable system so that other people can also add some features in it. And we have a web-based UI and an admin panel so that we don't need to work into the database directly. We can add new data throughout the system easily. And we developed that in AWS. We have CAPTCHA, email, mobile verification, activity log maintenance for security purpose. And we done the usability testing. So our future plan includes providing free API access. I'm sorry for the noise in the environment. It is the prayer time. I'm still sorry for that. Providing free API access, make the code base open access. And our another target is we want to share our data by de-identifying that and following the ethics so that the research community get some help. Like we were suffering because of we could not gather data easily. So we want to share that when we'll have a hectic amount of data. Adding more focused modules for specialized diseases like only heart disease or only kidney disease. This is our plan. Thanks everyone. That's all from my side. If you have any question, please feel free to ask.
Useful topic and nice presentation.
Thank you.
In the data transformation and augmentation, you are used the embedding of a information, right? In that, which algorithm you are used?
The embedding is using a fuzzy-wuzzy logic. This is a regular expression type things. And here we are just extracting data by by a pattern mining algorithm. We devised our own algorithm, and we have a plan to publish that in a journal so that we can have more space to publish that. And in that algorithm, we have used regular expression-based techniques.
Okay, and how you are taken care of a security, because you are taken
Yes.
the lots of data. So
Yeah. I have what I have mostly done here. I relied on the security of AWS, and another thing is I have been using CAPTCHA and email and phone verification. And always one of the team member is working on the log maintenance. They are doing some monitoring on the log so that no unauthorized access is performed there. Because we have a department here, they're working on that. So always a team member is there.
okay, thank you.
Thank you.
Thank you so much, Samyula. Thank
Thanks.
you.
Yep.
We move on further. We have our next presenter, Soma Yamamoto. Are you here? Soma?
Yeah. Hello.
Yes.
Can you hear me?
Yes, I can hear you. Can you share your screen, please?
Yeah. Can you see the screen?
Yes, I can.
Yeah. I will start.
Yes.
Hello, everyone. I'm Soma Yamamoto of Gunma University in Japan. The title of my presentation is Current-Driven IGBT Gate Driver Circuit, considering 4 operation regions. This talk, I will explain about these contents. First, I will talk about research background and objective. IGBT have some advantage of both MOSFETs and bipolar transistors. Recently, they are used in wide range of applications as power semiconductor devices. So development of IGBT and its driver circuit is important. IGBT is insulated gate bipolar transistor. The input part is MOSFET and the output part is bipolar transistor. IGBT have some advantages. For example, fast operating speed, a large current application factor, and high withstand voltage. On the other hand, there is a disadvantage that the large gate capacitance makes driver design difficult. There are 3 problems with IGBT circuit. First, parasitic capacitance and steady current cause switching loss. Second, parasitic inductance cause excessive overshoot. Third, change drive resistance during switching cause complex control. Therefore, we reduce switching loss and excessive overshoot, and we made a simple control design by current drive. Second, I will explain about IGBT evaluation circuit. This figure shows the voltage-driven IGBT evaluation circuit and its characteristics. Transistor 1 is an IGBT, and L2 is a parasitic inductance. The gate voltage VG is generated from V1. The gate voltage VG turn on IGBT, and the collector current IC gradually flows. At this time, the current flows in circuit like this. The input voltage V1 becomes 0. Gate voltage VG turn off the IGBT, and the collector current IC gradually decreases. At this time, the current flows in circuit like this. This graph shows the characteristics of overshoot and switching loss during turn off. When the gate resistance RG change from 30 ohm to 300 ohm. Next, I introduce IGBT current driver simulation. First, I explain about current gate driver circuit. This figure shows the current gate driver circuit and its characteristics. Input the constant current I1 to the current mirror circuit. The current I2 to I5 are determined by the amplification factor of each current mirror circuit. In consideration of 4 steps, the current I6 is the sum of the current I2 to I5 and controls the gate voltage of IGBT. Second, I explain the simulation result. The figure shows the IGBT evaluation circuit using current gate driver circuit and its characteristics during turn off. The gate voltage of IGBT is collected by the gate current IG. That's generated by the current gate driver circuit. Next, I will explain the 4 regions of current IG. The first is region 1. The gate voltage VG decreases for saturation voltage to mirror voltage. Region 1 has no effect on switching loss and overshoot. The second is region 2. The gate voltage VG is the mirror period. There is a trade-off between switching loss and slew rate. The slew rate of the collector voltage VG can be adjusted by the gate current IG. Therefore, it is possible to reduce switching loss in region 2. The third is region 3. In this region, the gate voltage VG decreases from the mirror voltage to the threshold voltage. There is a trade-off between switching loss and overshoot. The overshoot is the collector voltage VC can be adjusted by the gate current IG. Therefore, it is possible to reduce the overshoot in region 3. The last is region 4. In this region, the gate voltage VG decreases from the threshold voltage to 0 and switching ends. The gate current IG cannot be controlled due to current voltage characteristics of most FETs. Region 4 has no effect on switching loss and overshoot. This graph shows a comparison between voltage drive and current drive. The blue line is the voltage drive, and the red dot is current drive. For current drive, switching loss and overshoot are reduced. Switching loss is reduced by 35% and overshoot is reduced by 32%. Next, I will introduce gate current automatic control by analog value. Now we consider the automatic discrimination of the operation region of the current-driven IGBT gate driver. As shown in this figure, we try to determine the operation region automatically by observing the value of the IGBT gate voltage using an operational amplifier differentiator. Its model is universal op-amp 2, which is a general-purpose operational amplifier model provided by LT Spice. The output of differentiator with an operational amplifier is VU3. First, Figure A shows the ideal waveform of the output voltage VO3. But the actual observed waveform of VO3 is shown in this figure. And thus, we are able to observe the change in the slope of VG. Therefore, we are able to show the possibility of using the value of VO3 to automatically discriminate the operating region. On the other hand, VO3 is an analog value. It is unclear at which point the boundary of the operation region is determined. There is also the disadvantage that the actual VO3 is delayed in detection compared to the time of detection of ideal VO3. Next, I will introduce gate current automatic control by digital value. Next, we consider using the detector value of VO3 to represent the operation region as a digital value. Since VO3 is an analog value, it is unclear at which point the boundary of the operation region is determined. Therefore, the boundary between the operation region should be clarified by converting VO3 into 4 digital values. This figure shows the operation region discrimination circuit using comparators and reset flip-flops. The detected VO3 value is input to the comparators and converted into 4 digital values, RS1 to RS4, as shown in this figure. This enables real-time discrimination of the operation regions. Figure C shows the result of automatic discrimination of the operation region based on the 4 digital values of RS1 to RS4. As shown in this figure, observation of the IGBT gate voltage finally made it possible to discriminate the 4 operating regions for IGBT in real time. However, this method of detecting the operation region also has some problems. As shown in figure B, the boundary of the actual operating region is a point where the slope of VG changes. On the other hand, in the detected operation region shown in figure C, the rising edge of each of RS1 to RS4 is used as the boundary of the operating region. Comparing B and C, it can be seen that the detection timing of operating region transitions delay than the actual operating region. In the future, it is our task to verify how this delay in detecting the change in operating region affects the switching loss and overshoot. Finally, I talk about conclusion and challenges. Conclusion. Proposal of current drive circuit to control gate voltage of IGBT. During turn-off, when compared to conventional voltage drive, when current drive, switching loss reduced 35% and overshoot reduced 32%. Automatic discrimination of the operating region of current-driven IGBT gate driver circuit. A future challenge is to verify the effect of detection delay in the operating region change on switching loss and overshoot. Thank you very much.
Thank you, Samya, for informative presentation. In slide number 24, you are used the SR flip-flop, you are told us. Can you tell why you are used SR only there?
Are you asking about the purpose of this study?
Okay. Okay.
We think use the result of this automatic discrimination of the operating region to automatic control the current. So we think that automation of current will make it compare with the, for example, Internet of Things. Does that answer your question?
My question is why you are used, there are many flip-flops, right? You are used here SR. So what is the reason behind that? Just I want to know.
Sorry, I'm having trouble understanding your question. If you have time later, could you ask me a question in the Zoom chat?
Hello. My question is why you are chosen there SR flip-flop? There are many flip-flops available, right? Getting me?
Sorry, I'm having trouble understanding your question.
Okay, fine. Okay, have you validated your circuit with any application?
Are you asking about the we think
I think we can drop a chat if he's not understanding the language. Chat option would work.
Sorry, I'm having trouble understanding your question.
Yeah. So she'll drop a question on the chat option. Yeah. Chat forum is open. That would work because as we are running late, we have the other presenter waiting.
Which simulator you are use? Last question. Which simulator you are use?
We use LT Spice. This simulation solved.
Okay, thank you.
Thank you. Thank you so much.
Thank you.
Thank you. So we have our next presenter. Rastislav Roka, you here now? Can you hear me? Can you hear me? Rastislav? Yes, please start sharing your screen. Has some connectivity issue. Can I start from your presentation? Yes, Lani, you can take the screenshot. I have just shared the screen.
Thank you.
Can I stop the screen now?
Yeah, thank you.
Thank you. We'll wait for another 2-3 minutes. If the presenter gets joined back, all of us will end the meeting. 5 minutes, please. Can the participants on the camera for a quick snapshot? Thank you. We are waiting for the presenter to rejoin. I'll just wait for him.
I like to present my contribution that is related to the performance analysis of TDM-PON protection schemes by means of the TDM-PON network availability evaluator. So, what's the motivation for this contribution? There are many network operators permanently develop TDM-based passive optical networks, eventually with a moderate upgrade to hybrid passive optical networks. But
Voice problem again.
I cannot hear you, Rastislav. Thank you, Rastislav Roka. So the questions will get directly on your chat option because we're not able to hear you now again. Yes, there's a problem with the sound again. So sorry, I can't help you now. I can't help it. Okay.
Okay, thank you. Can you please tell your system recovery time and the cost?
Not able to hear us as well now. So question through. Anyways, so we'll move further. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I also thank our session chair, Dr. Latika Desai, for chairing the session. A token of appreciation for you, ma'am, on behalf of Team ICICT 2022 and Global Knowledge Research Foundation. Thank you for your presence, ma'am. Thank you so much.
Thank you, Deepika. All researchers presented their paper very nicely. Thank you, Dr. Amit Joshi, sir, and the team for inviting me as a session chair for the 7th International Congress on Information and Communication Technology. Thank you.
Bye, stay safe, take care. Rastislav Roka will take a leave now. Stay safe. Bye-bye. I will have to message you. Thank you. Thank you. Bye. Goodbye. Take care.